everyone, we're going to evaluate the integral from 0 to pi divided by 2 of sine x divided by 1 plus cosine squared x dx. Alright, so the first thing let's do is go ahead and use u substitution. I'm going to let u equal negative cosine of x. Therefore, du is going to be just sine x dx. And basically that's why I let u equal that, because I had sine x dx. So I did the antiderivative and got negative cosine of x. I let that be u. And then we're pretty much ready to start, except we have to now change our upper and lower limits. So let's if x is 0, we have negative cosine of 0. And cosine of 0 is 1. So that would mean u equals, this is u, would equal negative 1. And then if we have pi over 2, if x is pi divided by 2, that's going to be negative cosine of pi divided by 2. So that means your u is going to be 0, because cosine of pi divided by 2 is 0. So now let's change our limits from negative 1 to 0. So this is your lower, this was your upper. And then we have sine x dx, that's du. And then our negative cosine of x is our u. So basically we can write this as 1 plus u squared. Because u squared, if you square this, would be a positive cosine. We'd get that back. All right. So now we can differentiate that. Let's look at what we have. This is really 1 divided by 1 plus u squared. And that is this form right here. So that's inverse tan. So we're going to write this as inverse tan of u. And we're evaluating from negative 1 to 0. So this is going to be inverse tan of 0 minus inverse tan of negative 1. All right, so inverse tan of 0 is just 0 minus inverse tan of negative 1. That means, remember, the restrictions on inverse is quadrants 1 and 4. Since it's negative, we're in quadrant 4. So that's going to be just negative pi divided by 4. All right, and so that final answer is going to equal pi divided by 4. And that's your final answer. Thank you. Have a nice day. Bye-bye.